Hello everyone, welcome to my video tutorial on Bresenhams line drawing algorithm. So what is Bresenham lines algorithm? It is actually a line drawing algorithm, the other one that we have explained before, DDA. And here we will be using incremental integer calculation. This Bresenham's line drawing algorithm can be adapted to display circles and other curves. So we will be using a modified version of Bresenham lines algorithm to display circles and curves as well. When sampling at unit x intervals, we need to decide which of two possible pixel position is closer to the line path at its sample step by using a decision parameter. We will explain this later. In Bresenham lines algorithm, we have a decision parameters pk. Try to understand this. It is an integer number that is proportional to the difference between the separation of two pixel position from the actual line. Depending on the slope sign and value, the decision parameter determine which pixel coordinates would be taken in the next step. So the most important part about Bresenham line algorithm is that we will have a decision parameter. We will take a difference between two pixel position and try to find the value which is closest to the next pixel, and decision will be taken accordingly. Okay. So here is an example. pk, this decision parameter for line with positive slope less than 1. As you can see, sampling is taken at unit x intervals. At pixel xk, yk, we need to decide whether xk plus 1, yk, or xk plus 1, yk plus 1 will be plotted in column xk plus 1. Okay, so here what we have is, this part is, suppose this line is xk line and this is your yk line. Okay, and as you can see, this, if this is your xk line, this one will be xk plus 1, this one will be yk plus 1. All right, this, the horizontal line will be x and the vertical line will be yk plus 1. So we are here in this particular point. Initially, this point is called xk yk. Suppose we have a straight line like this. This is your straight line, and we are trying to plot a straight line into a pixel. That is the problem. This straight line is a vector line, but we cannot have a vector line using a digital pixel display. So we need to find the pixel closest to this line. All right, so we have two choices in this particular example. In this example, we have two choices. One is this point or the below point, the upper point or the below point. And as you can see from here, the coordinate of the below pixel is xk plus 1 comma yk. All right, this is xk plus 1 incremented by 1. This is yk. Actually, it should be written, all this plus 1 should be in subscript. All right, this also. This line is closer to this point. So in this example, we have to choose the closer point, which will be decided by your pk. This is your decision parameter. We will show how it is done. All right. Y coordinates on the mathematical line at pixel xk plus 1 is calculated as y equals to x plus 1 m b m plus b. This is a formula of line. And d1 is equal to y minus yk, d2 is equal to yk plus 1 minus y, and pk is equals to delta x d1 minus d2. So this is a formula for mathematical line, but in pixel form we have another formula. We will discuss this. Property of px for line with positive slope less than 1. If the pixel at yk is closer to the line path, then the pixel yk plus 1, that is d1 is less than d2, then decision parameter pk is negative and we plot the lower pixel. On reverse, pk is positive and we plot the upper pixel. So whether we choose the lower pixel or the upper pixel will be decided by the decision parameter pk. Okay, so if pk is 0, then choose either yk plus 1 for all such cases or yk. So if pk is equals to 0, then it doesn't really matter. All right, we will come to the computer graphics point of view. Properties of pk for line with positive slope less than 1. Incremental integer calculations can be used to obtain values of successive decision parameters because change occur on either x or y coordinates. Pk plus 1 equals to pk plus 2 delta y minus 2 delta x bracket yk plus 1 minus yk close bracket, and p0, this is the initial decision parameter. Initially we will calculate this. P0 is equals to 2 delta y minus delta x. Okay, these two formula you will have to remember. This is a very important formula. All right, you will have to remember for Bresenham line algorithm. Now, suppose this is an example, drawing the line between the endpoints 3, 3 and 2, 3, 1, 3. The endpoint here, we will start from here, is, as you can see, 3 on the x-axis and 3 on the y-axis. And this particular point is also 23 on the x-axis and 13 on the y-axis. As we can see from here, if we calculate m, the slope, you will get 0.5. But in Bresenham line algorithm, what we need is to find the differences between the endpoints. All right, so here we will calculate delta x is equals to x endpoints, let's say x2 minus x1, which is equals to 23 minus 3. Now we will get delta x is equal to 20. Likewise, delta y will be this 13 on the y-axis minus 3. 13 minus 3, which will be equals to 10. As you can see from here, delta x is equal to 20 and delta y is equal to 10. So the initial p0 will be 2 delta y minus delta x will be equals to 0. Okay, before we solve that example, let us take a look back on how Bresenham line drawing algorithm works. This is your algorithm. You will have to remember these steps. Step 1, we start. Step 2, we take the endpoints 1 and endpoints 2, x1, y1, x2, y2. Now we calculate the differences. Now we get delta y and delta x. And from that, we calculate the initial decision parameter p0 equal to 2 delta y minus delta x. You will have to remember this. And for every movement from pixel to pixel, calculate next parameter px plus 1 equals to px plus 2 delta y minus 2 delta x within bracket x y k plus 1 minus yk. All right. And here is the most important part. If the resultant decision parameter is, if pk is greater than or equals to 0, x will be incremented, y will also be incremented. All right, try to remember this. And if the calculated decision parameter is less than 0, x will be incremented, y will remain the same. Okay, and after this we will repeat the steps until we reach the other endpoint. We will start from here, and until we reach here, we will repeat from step 5. All right, this is your algorithm. Now let us calculate that particular example that we saw before. This is a simple example, the same example where we have to calculate a value from 3 to 23, 13, the same example. So in this, the same example that we have, I'll just show you again this example 3, 3, 23, this particular line. All right, so what we need is, first step, we have to find the delta x and delta y. We already find this value, and then we have to find this p0. And if we calculate this p0, we know that 2 into delta y is 10 minus delta x 20, which is equals to nothing but 0. Okay, now your p0 is 0. All right, then the next thing we have to calculate it is the next value of decision parameter. We have this formula pk plus 2 delta y minus 2 delta x. We know this delta y and delta x, so delta y is 10, so 2 into 10 is 20 here. I'll just simply put 20 here. Delta x is also 20, and 2 into 20 is 40. We can simply put it here. All right, and then this is the next value Using this formula, we will try to calculate the next decision we have to take for each of the pixel movement. Okay, initially we have 3 into 3. This is the initial point, and we have to move to 2313 as we know before. So what we need is, first we already calculate p0, so we have p0, and k is also 0 here. There is no increment in the beginning, so k is 0 here, and p is also 0. The next is simply 4 into 4, 4, 4. All right, so when there is nothing to calculate, you simply increment 3 into 4, and from on the y-axis also 3 into 4. All right, so this is how it works. Now what we need to do is we have to calculate the value of decision parameters for each pixel. Now let's say when k is equals to 1, what will be the value? Now let's see, pk, when k is equals to 1, p will be 1, p1 will be equals to p0 plus 20 minus 40, and yk is what? This is what your yk plus 1, this is your yk. All right, so it means 4 minus 3. What the value that we have here is p0 is 0, this is 20 minus 40. 40 into 1 is nothing, and then if we calculate this, we will get minus 20. All right, p1 will get minus 20. And from the decision parameters that we have, if the value of p1 is minus 20, what do? We increment the x, and y is same. All right, so we increment x from 4 to 5, and y is same, means 4 and 4. All right, now we calculate the value for p2. For p2 we need p1 plus 20 minus 40, and here what is the value of yk plus 1 minus yk? Your yk plus 1 is 4, and your yk is 4. All right, see, this is the initiate anai berso ka yk plus 1 ninga next hi mache mi ka yk ni don dinani. So what we get here is p1 is minus 20. We already know here p1 is minus 20 plus 20 minus 40 into 0, which is equals to minus 20 plus 20 minus 0, which is equals to 0. So when it is 0, x will be incremented, y will be incremented. Okay, so x is incremented from 5 to 6, y is incremented from 4 to 5. All right, let us try once more. Now let's move another k. p3 is equals to p2 plus 20 minus 40. What is the value of yk plus 1? 5. Here is your yk plus 1. And what is your value of yk? 4. 5 minus 4. So you will get p2 is nothing but 0. Here we get 0 plus 20 minus 40 into 1. If we calculate this, you will get minus 20. So when we get minus 20, what do? X will be incremented, y will be same. All right, so when we get this, what we have is x will be incremented by 1. It comes from 6 to 7. Y will be the same, 5 and 5. All right, this is how it is calculated. Now let us try to plot this particular example. You start from 3, 3. Now we end at 23, 13. So the movement that we make using a pixel is that when we calculate like this, the first step is 4 and 4. Here is 4 and 4. Next step is 5 and 4. Here is your 5. This is your 5, 4. Okay, and then you get 6, 5. Here you see all these things, 6 and then 5. This is our 6, 5. and then 7 5 8 6 9 6 and so on. If you see all these things, if you draw a plot in, if you plot all these things, you will get a line like this. All right, so this is the line drawing algorithm using Bresenhams. Thank you.